This is the MDi direct injection diesel engine from Rover. It's the result of years of joint development between Perkins and Rover and incorporates some revolutionary concepts. The engine uses a single overhead camshaft driven by a toothed belt which also drives the fuel injection pump. The engine number is stamped on a pad on the cylinder block, next to the dipstick. There are just two versions, BA, naturally aspirated, BB, turbocharged. The oil filter is a disposable canister fitted on the externally mounted oil pump. The oil pump incorporates the pressure relief valve and is driven from the front of the crankshaft. The thermostat is of the flanged type, with an internal bypass. The exhaust and inlet manifolds are mounted on the same side of the cylinder head, and the naturally aspirated version has 4 tuned length inlet pipes. Together with the carefully designed inlet passage, this provides the high swirl and turbulence necessary for high-speed performance. The low inertia turbocharger, if fitted, is attached to the exhaust manifold. A wastegate is fitted to limit maximum boost pressure. Its boost pressure sensor is attached to the wastegate control mechanism. This allows the turbocharger to respond very quickly to any demands made on the engine and gives boost low down the speed range while controlling maximum boost within safe limits. Mounted on the camshaft cover are the vacuum pump and the fuel lift pump. The vacuum pump, or exhauster, provides a vacuum for servo braking systems. This is required because the diesel engine has no throttle disc to create manifold vacuum. Both vacuum and fuel lift pumps are driven by eccentric lobes on the camshaft. With all fuel injection systems, a high degree of protection from dirt and water is required. To achieve this, a disposable fine mesh filter is fitted. It has a water drain valve at the base. This filter protects both the injection pump and the injectors. The engine uses a closed-circuit breathing system positioned on the oil filler tube to stop excess pressure building up in the crankcase. On turbocharged cars, piston cooling jets are fitted in the crankcase. These give a continuous oil spray onto the underside of the piston crown. A vapor separator on the inner wing prevents air from the fuel tank being passed to the injection system. Fuel enters from the lift pump, and any trapped air escapes through the center outlet to the spill return pipe. As there is no ignition system to run a standard tachometer, a special optical tachometer is used to check engine speed when setting fast and normal idle. To achieve true high-speed direct injection has been the aim of diesel engine manufacturers for many years. With computer-aided design, the MDi has now achieved the same. A high turbulence and short ignition delay period are the direct result of this careful design. The pistons and weight balance connecting rods are attached to a 5-main bearing crankshaft. Finally, the addition of glow plugs gives the engine effortless starting even at temperatures below freezing. All these features combine to give a world first, a truly high-speed direct injection diesel. Low-cost maintenance and ease of servicing are desirable features for customers and repair personnel alike. With the MDi, great attention has been given to both. Direct injection brings high performance and superb fuel economy with excellent torque characteristics. A hidden benefit is an extension of service interval, in some cases as much as twice that of a comparable indirectly injected engine. Combine this with mechanical integrity and servicing is halved at a stroke. Oil, coolant and filter checks and changes are routine, so we'll examine the more detailed tasks. One of the jobs to be carried out is the valve tip clearance check or tappet adjustment. Remove the timing belt cover, this small screw, and the blanking plug from the cam cover. Rotate the engine until the timing pin drops into the camshaft. This aids removal of the fuel lift pump and exhauster. Remove the camshaft rear cover or the steering pump pulley if it's a Montego and fit this special tool to hold the camshaft down while the top cover is removed. Undo the screws in the reverse order of tightening. Then lift off the cover with its thrust washer. The clamping load on the camshaft will affect the adjustments you have to make, so clamp the shaft down loosely using the special tools. Make sure the contour of the pad matches the shape of the journal. Turn the camshaft until 2 cam lobes are vertical and tighten the clamp bolts. Measure all clearances between the back of each camshaft lobe and the tappet, and note them down. Repeat the procedure on all cam lobes. The clearances will need adjusting if the gaps are outside the limit stated in the repair manual. If adjustment of one or more of the clearances is found to be necessary, rotate the crankshaft until the timing hole in number 1 camshaft journal is at 12 o'clock. Then fit a timing pin through the engine backplate into a hole in the flywheel. Fit the fuel injection pump pulley holding pins to keep the pulley in its timed position when the belt's removed. Lock the crankshaft, loosen the crankshaft pulley bolts and remove the pulley. Remove the drive belt tensioner. Using the holding tool to restrain the gear, loosen the camshaft gear screws. Remove the belt. Then, using a holding tool, remove the gear. Remove the camshaft retainer and clamps. Lift out the camshaft and remove the oil seals. It's important that tappets are adjusted one at a time. Remove the cam follower and take out the shims. Measure the thickness. There are 18 shims of different thickness, ranging from 2.31 millimeters to 3.17 millimeters. There's a simple way of deciding which shim to select. Where A is the existing clearance that you first measured, B is the thickness of the shim removed from the engine, C is the standard tappet clearance obtained in the repair manual. Add A plus B and take away C to give you the shim required. For example, if A equals 0.50 millimeters, B equals 2.56 millimeters, and C equals 0.40 millimeters, the shim required will be 2.66 millimeters. When the new shim has been selected, fit it into the recess in the tappet. Lubricate the tappet and replace it. When all clearances have been adjusted, clean and lightly oil camshaft journals and cam, and put the camshaft into position with the timing hole in number 1 journal at 12 o'clock. After cleaning the mating faces of the top cover, apply a thin bead of Hylosil 102 to the outside grooves. Ensure the camshaft thrust washer is in place. Then fit the cover immediately. Fit the screws and tighten down evenly, in the order shown in the repair manual, to the correct torque. Fit the camshaft timing pin through the hole in the top cover and fit new oil seals using the special tools. Fit the timing case top cover screw and fit the rear camshaft cover. There are several other repairs and operations which will require you to remove and replace the cam belt, namely water pump removal or replacement, oil pump removal or replacement, fuel injection pump removal or replacement, cylinder head removal, or simply if the belt has to be changed. All of these operations will require the engine to be retimed and the drive belt retensioned. A word of caution here. Never rotate the crankshaft while the drive belt is removed, or the pistons will hit the valves. Ensure first that all pins are fitted in the camshaft, crankshaft, and fuel injection pump drive gear. Hold the camshaft gear, then fit and tighten the center bolt to the correct torque. Fit the belt, ensuring the arrows on the belt point in the direction of rotation. Remove the holding pins from the fuel injection pump gear. Ensure the flywheel locking tool is fitted to the starter recess. Fit the crankshaft pulley and tighten to the correct torque. Then remove the locking tool. Fit and lightly load the tensioning pulley, turning it anti-clockwise. Tighten the camshaft gear screws and remove both timing pins. Turn the engine through 2 revolutions to equalize the belt tension and make sure there are no obstructions. Fit the tension gauge and check the belt tension. Refit the timing pins to the camshaft and flywheel. Loosen the camshaft gear screws. Adjust the belt tension and retighten the 4 screws. After any adjustment to the belt, always remove the timing pins and rotate the engine twice before checking the tension. With the camshaft timing now correct and the belt at the correct tension, we must now check and adjust the fuel injection pump timing. The point at which fuel is injected into the combustion chamber has a great effect on the performance and efficiency of a diesel engine, so accurate timing of the fuel injection pump is essential. Turn the engine clockwise from the front until the camshaft and crankshaft timing pins can be fitted. Remove the blanking screw from the injector and in its place fit the adapter and dial indicator gauge. Preload the gauge and clamp it with the locking ring. Remove the timing pins and turn the engine anti-clockwise until the pointer stops moving. Zero the gauge. Now turn the engine clockwise until the flywheel pin drops into position and take the gauge reading. Check for the correct reading in the repair manual. If the gauge reads within 0.03 millimeters of this, the timing is correct. If a reading is outside specified limits, the high-pressure pipes must be disconnected. The rear mounting flange bolts loosened and the 3 front flange bolts loosened. The pump must be turned on its slotted mounting holes to achieve the correct timing. Always make the final movement of the pump towards the cylinder head to achieve the correct reading. When timing is correct, tighten the flange mounting nuts and remove the flywheel timing pin. Turn the engine anti-clockwise until the pointer stops moving, then forward again until the pin can be fitted. Ensure the gauge reading is still correct. We can demonstrate why it's so important to use the flywheel timing pin for injection pump timing. When the camshaft timing pin is used, you can see the sort of error you're faced with. However, when the flywheel pin is used, the needle remains steady. Remove the timing gauge and fit the blanking plug, tightening up to the correct torque. Don't forget to tighten the remaining pump screws and high-pressure pipe unions. You've now been introduced to new service techniques and operations. These are, of course, laid out in easy step-by-step form in the repair manual. We've also seen a whole range of special tools. First, the timing pins, used for many jobs. The camshaft retainer and clamps for tappet adjustment. The oil seal replacers. There are also 3 oil seal removers of the screw-in type. The belt tensioning gauge and the fuel injection pump timing adapter and gauge. In the following sections, we'll take a look at the other special tools. Now, the major strip and rebuild operations of the MDi Diesel Engine. To remove the cylinder head, the top cover and camshaft need not be removed, but the timing pins must be fitted and the coolant drained. Remove the alternator drive belt and water pump pulley. Remove the exhauster, undoing the short bolts first. Remove the high-pressure pipe assembly. Dirt must not be allowed to enter the pump, so blank it off. Remove the injectors and their washers. Protect the tips. Then remove the glow plugs. The drive belt and camshaft gear can now be removed. On later cars, you'll need to remove the water pump to gain access to this screw. Release the cylinder head bolts evenly in the reverse tightening order to avoid distortion. Diesel engines work at high in-cylinder pressures, and distortion of the aluminium cylinder head could give rise to later gasket failure. Remove bolts and cylinder head, remembering to place the head on wooden blocks to prevent any damage. Complete cylinder head overhaul can be carried out. The procedures are, of course, in the repair manual. A new cylinder head gasket must always be used. This locates on two dowels. To fit the cylinder head, ensure the head face is clean and both the camshaft and flywheel timing pins are fitted. Check all the bolts, looking for any narrowing. If this is apparent, use a new bolt. Fit all bolts and tighten down in order to 50 Newton meters. Repeat this tightening to 100 Newton meters. Finally, in the same sequence, tighten all bolts a further 90 degrees. This procedure eliminates the need for any further tightening. Fit all other components. Fit the glow plugs using a copper-based grease on the threads. These glow plugs have tapered seats and the correct torque must be used. Fit the injectors with a new nozzle washer to each. These must be renewed every time an injector is replaced. Tighten the injector clamp bolt to the correct torque. High-pressure pipes are particularly prone to damage from over-tightening, and this can cause performance problems. A misfire can be caused by disturbing the delivery valves. So hold these securely whilst tightening or undoing the pipe unions. Fit the timing belt. Tension it and check the fuel injection pump timing as we've already seen. Because the injection pump is self-bleeding, the fuel system will clear itself of air by simply cranking the engine on the starter motor. However, to save the battery, the filter has a bleed point here. Loosen this and prime using the lift pump. This will expel air from the filter and fill it with fuel. The main bearing caps have front stamped on them and numbers indicating their position in the engine. Number 1 is at the oil pump end. The crankshaft end float is controlled by 4 thrust washers, 2 on each side of the center main bearing. If the end float is outside the limits shown, the thrust washers can be replaced. Now, remove the crankshaft. The crankshaft can be reground by 0.30 millimeters and undersized bearings fitted. The upper half of the bearings are drilled and grooved for oil passage, and the lower half are plain. If excessive bore wear is found and rebore is necessary, 0.50 millimeters oversized pistons are available. If a major overhaul is called for, a prime consideration is to maintain the compression ratio evenly between cylinders. This is controlled by careful selection of piston heights. Height grade is shown stamped on the piston crown as numbers 1 to 6. The replacement piston in service for numbers 1, 2 or 3 is 3, and for 4, 5 or 6 it will be 6. So for the one shown it will be 3. The connecting rods are fitted as a weight-balanced set and are stamped with the cylinder numbers. When reassembling, place the cap onto the rod with the cylinder numbers together. Always fit the pistons with protection on the conrod bolts to prevent crankshaft damage. Whichever pistons are fitted, it'll be necessary to check piston height after fitting. This is easily done using a dial gauge. But of course the piston must be at its highest point, of exactly top dead center. Position the dial gauge stylus on the highest part of the piston crown. Rotate the engine clockwise until the needle stops moving. If it goes past, turn the engine back and try again. Once this is found, we set the gauge to 0 on the block face. Then transfer the stylus back to piston crown. The reading obtained must be checked against the limits shown in the repair manual. The oil seal for the rear of the crankshaft is carried in the back plate. In service, the seal is fitted flush with this face. From the factory, it must be fitted flush with this face. This tool is supplied to drift it home. The remaining components can now be fitted. Back plate using the seal protection sleeve. Oil pump. At this stage, apply Loctite 518 to the back plate until it just exudes from the slots. With the oil pump pickup pipe replaced, the sump must now be fitted within 5 minutes before the sealant starts to cure. All these procedures are, of course, gone into in detailed step-by-step instructions in the repair manual. Let's look at some of the important points we've covered. Fuel injection equipment must be kept scrupulously clean and protected. The cylinder head, being aluminium, must also be carefully treated. Don't forget to loosen and tighten the head bolts in the correct order. Never fit the cylinder head without the 2 timing pins being fitted. Remember to always fit new nozzle washers. Care here can save many problems later. Selection of piston height and careful measurement will ensure peak efficiency. Make sure that main bearing shells are correctly fitted. Top half grooved, lower half plain. Big end caps and rods are matched. Remember the numbers? Protect the crankshaft from damage and always use the correct sealants for leak-free operation. That concludes our look into the MDi Diesel Engine. The next section introduces some basic fault diagnosis procedures. The MDi Diesel Engine has been designed to provide many years of trouble-free operation with a minimum of attention. Nevertheless, with any complex piece of precision machinery, faults can develop for a variety of reasons, and diagnosis in the workshop or in the field can be a difficult task unless correctly approached. Faults are often reported by people who know little or nothing about their engine, and will be reported in their terms. It smells, it doesn't roll, it's noisy, and so on. Listen carefully, then check the fault if possible with a road test. There are certain checks to carry out for each specific fault. You'll find that the same checks may be used for many different reported faults. This will be noticed when you check the fault diagnosis chart in the repair manual. Reported faults normally fall into 5 main areas. The engine will not start. The engine lacks power or misfires. The engine starts, then stops. Excessive exhaust smoke, white. Excessive exhaust smoke, black. The reported fault, excessive exhaust smoke, may in fact be one of 2 other faults. These would be smoke accompanied by misfiring or uneven running, and smoke with loss of power and poor fuel consumption. All 5 major reported faults can normally be resolved by checks carried out to 4 different areas: the induction system, the electrical system, the fuel system, the engine itself. Some faults will require only one system to be checked, others all four. Engine will not start, for example, may require all four systems to be checked. Always investigate the basics first. Remove the fuel filler cap and listen for the hiss of air entering the tank. This would indicate the fuel tank breather is blocked and a partial vacuum formed in the fuel tank, preventing fuel from reaching the engine. While the cap is off, smell the fuel. It's not unknown for petrol to have been put in by mistake. Check for any obvious damage to the fuel system at the engine. Are there any broken pipes or obvious leaks? Look at the air system. A flattened pipe or badly blocked air cleaner may be the answer. Having checked for obvious problems in the four areas, reference can now be made to the fault diagnosis chart in the repair manual. We'll use the reported faults no start and difficult start. Starts but misfires after start. For no start or difficult start, first check the battery. Make sure it's fully charged and carry out a heavy discharge test using the fast check. Check the starter circuit for high resistance. Remember, a loose engine earth connection will cause sluggish cranking. If your engine analyzer has a high current ammeter, check the current drawn when cranking. A high reading could mean the engine's tight. Try turning the crank. If the engine's quite loose, then suspect a faulty starter. If the engine starts but misfires after startup, the glow plugs may be suspect. This instrument measures the current drop over a 20-second period with the plugs either in or out of the engine. A high compression ratio on a diesel engine is essential. The cylinder compression can tell us a great deal about the condition of the engine. To check cylinder compression, remove all the injectors, the locating rings and copper washers. Using an old seating washer, fit this adapter and gauge. Crank the engine until the reading remains steady. Note it down and move to the next cylinder. The actual pressure achieved depends on how fast the engine is cranked, the temperature of the engine, and so on. An actual figure then is not given. Rather, we'd look for a noticeable difference in pressure between cylinders. For example, 3 cylinders at around 27.2 bar and 1 at, say, 14.3 would tell us that there's a loss of compression in the cylinder with a low reading. If you do find a low reading, squirt a few cc's of oil into the cylinder and repeat the test. If the reading increases significantly, the problem is worn piston rings or cylinder bore. If not, then look for a burnt valve or blown head gasket. The engine is stopped by means of this solenoid valve on the fuel injection pump. If it's not working properly or it's disconnected, the engine won't start. The solenoid should be heard to click when the ignition is turned on and off. If no click is heard, either the solenoid is faulty or the wire is open circuit. For white smoke, check the air cleaner is not blocked or dirty. This is easily done by removing the element and running the engine for a short while without it. If the engine lacks power, first check the fault diagnosis guide in the repair manual. But always check the fuel filter. Ensure that all water is drained off by undoing the water drain here. Is fuel reaching the injector pump? Check by loosening the fuel feed line at the pump and turning the engine on the starter. If there's uneven running or misfire, remove all the injectors and check them for correct operating pressures and spray quality. The pressures can be found in the repair manual. If there's a faulty injector, this could also account for black smoke problems, high fuel consumption and engine noise. Whilst looking for smoke problems, the fuel injection pump timing must be taken into account. Check it. If the pump is retarded, a white smoke problem will occur. If advanced, black smoke and increased engine noise. These then are the most common faults. Remember, a comprehensive fault diagnosis chart is contained in the repair manual supplement. A diesel engine needs clean fuel, presented in the right form and at the right time. An unrestricted supply of filtered air. And because of the high compression ratios, good, well-maintained electrical equipment for starting. With these few simple precautions and with regular maintenance, your MDi diesel engine will provide you with many years of trouble-free service.